Good day. Welcome to class. In today's class, we are going to be considering electric field 3. Electric field 3. We will look at a problem, 2-point charges, plus 30 coulomb and plus 11 coulomb, separated by 20 centimeter. We are to compute the electric field intensity and the force on a plus 5 times 10 raised to power minus 6 coulomb charge placed midway between the charges. Alright, so we have our setup as is shown in the diagram here. This is the plus 30 coulomb charge. This is the plus 10 coulomb charge. This is the midpoint between the charges. If the distance between the two charges is 20 centimeter, the midpoint will be 10 centimeter from 30 coulomb and will also be 10 centimeter from 10 coulomb. Good. Now, this is where the secret lies. Assume a test charge that is placed at point P. What is a test charge? A test charge is a charge that is so small that its electric field, that is the electric field around it, will not disrupt the electric field of the setup, of the charges in the setup. Okay, that its electric field, that is the electric field of the test charge, will not disrupt or affect or scatter the electric field of the plus 30 coulomb and the plus 10 coulomb charges. Good. Now, if you place a positive test charge at point P, you place a positive test charge at point P, what will happen to the positive test charge as a result of the plus 30 coulomb charge? The plus 30 coulomb charge will repel the positive test charge to the right, okay, to your right. It will repel the positive test charge to your right. Okay, good. What will happen to the positive test charge that you place at P as a result of the plus 10 coulomb charge here? The plus 10 coulomb charge will also repel the positive test charge to the left. Okay, it will repel the plus 10 coulomb charge, will repel the positive test charge placed at P to the left. Alright, so we have two repulsion, one to the right and the other one to the left. Okay, so that means that the electric field intensity will also be the direction of the force of repulsion, will also be the direction of the electric field intensity. Take note of that. The direction of the force of repulsion or attraction is also the direction of the electric field intensity. Alright, having said that, it means that if on the positive test charge that is placed at point P, two forces are acting on that test charge, the one that is repelling it to the right as a result of the plus 30 coulomb charge and the one that is repelling it to the left as a result of the plus 10 coulomb charge. If we are now to get the resultant electric field at point P, if we want to get the resultant electric field at point P, what we'll do is we will subtract the electric field at point P as a result of the plus 10 coulomb charge minus the electric field at point P as a result of the plus 10 coulomb charge. Okay, so we will subtract normally, and that is what we have done in this place. Okay, so let's go over them one after the other. If I'm to calculate electric field intensity, E is equal to KQ all over R squared. Electric field intensity E is equals to KQ all over R squared. So this is the formula that I will use, and it's not difficult to get this formula. We have obtained this formula from E is equals to F over Q. If we substitute the F into the F, which is KQ capital Q small q all over R squared divided by small letter q will cancel one another, and so we'll be left with KQ all over R squared. If we substitute correctly, our K is a constant, that is 9 times 10 raised to power 9. Then our Q, that is the plus 30 coulomb charge. We are calculating the electric field of the plus 30 coulomb charge at point P. That will be times 30 divided by 0.1 square. How did we get 0.1 square? 0.1 is the distance between the 30 coulomb charge and point P. That is 10 centimeter. If we convert the 10 centimeter to meter, that will be 10 divided by 100, and that will give us 0.1, then square from the formula. Square. Now we'll do the same thing for our electric field intensity as a result of the 10 coulomb charge. Okay, so we also substitute, which is KQ all over R squared. Our K is 9 times 10 raised to power 9 multiplied by our Q now is 10 coulomb, the 10 coulomb charge, and the distance from the 10 coulomb charge to point P, where we want to calculate the electric field intensity, okay, is also 10 centimeter. If you convert 10 centimeter to meter, that will be divided by 100, and that will give us 0.1, then square, the square from our formula. Good. Now, how then do we calculate the electric field intensity, the resultant electric field intensity? Another person may call it the net electric field intensity. Either you call it the resultant electric field intensity, or you call it the net electric field intensity. That is what we have represented with capital letter E, which is the resultant electric field intensity or the net electric field intensity. Okay, so we'll get that at point P. The resultant electric field intensity at point P would be given by the electric field intensity as a result of the 30 coulomb charge minus the electric field intensity as a result of the 10 coulomb charge. Good. If we substitute, we will discover that 9 times 10 raised to power 9 is common. By the time we substitute what we have here for the electric field intensity as a result of the 30 coulomb, and we substitute what we have here as the electric field intensity as a result of the 10 coulomb charge, we'll find out that 9 times 10 raised to power 9 is common. Okay, so we bring it out. We are left with 30 all over 0.1 squared minus 10 all over 0.1 squared. Good. We also discovered that 0.1 square is common, so we factorize it out. So 0.1 squared, we factorize it out. we are left with 30 minus 10 in the bracket, and that of course will give us 20. Okay, so we have 9 times 10 raised to power 9 multiplied by 20, all divided by 0.1 squared, and that, if we press our calculator correctly, that will give us 1.8 times 10 raised to power 13 Newton per coulomb. 1.8 times 10 raised to power 13 Newton per coulomb. 1.8 times 10 raised to power 13 Newton per coulomb. Okay, so the unit of electric field intensity is Newton per coulomb. Newton per coulomb. Don't forget, the definition of electric field intensity is force per unit charge at a point. Force per, per unit charge at a point. Good. All right. Now we are not through. We have been able to calculate the net electric field intensity at point P. We have been able to calculate the net electric field intensity at point P. If they now place a charge of plus 5 times 10 raised to power minus 6 coulomb, if a charge of plus 5 times 10 raised to power minus 6 coulomb is placed at point P, what will be the force that will be experienced by that charge? What will be the force that will be experienced by that charge? Okay, now to do that, that is to calculate the force that will be experienced by that charge, don't forget our definition of electric field intensity, which is what? Force per unit charge. Okay, so if we cross multiply F, which is the force that will be experienced at point P, is equals to QE. F is equals to QE, that is the force that will be experienced at point P is equals to the charge multiplied by the resultant electric field intensity. This is it here. The charge multiplied by the resultant electric field intensity. The charge placed at point P multiplied by the resultant electric field intensity. Okay, multiplied by the resultant electric field intensity. So if we now put the charge that we are just putting at point P, which is plus 5 times 10 raised to power minus 6, we put it here, multiplied by the resultant electric field intensity that we just calculated. The resultant electric field intensity that we just calculated, which is 1.8 times 10 raised to power 13 Newton per coulomb. Okay, so put it here. By the time we multiply it, it will give us 9.0 times 10 raised to power 7 Newton. 9.0 times 10 raised to power 7 Newton. Now we have been able to calculate the force that will be experienced by this charge placed at point P, and that is our goal. That is what we are asked to calculate. Thank you for your listening attention. See you in the next class. Bye.